Okay guys, welcome back to the video series on how to code a cryptocurrency in Python. It's been over a year now and I decided I was going to continue making these videos because of the comments I've received in the last two. And now that I have some time here and with the whole COVID-19 situation, I'm going to be coding the next few videos for this series. So I guess diving right back into where we left off a while ago, there are a couple things I'd like to change after a year of letting this file sit. There's some things that I wish I would have done differently, and just a really small thing is in the past we had been creating the blockchain as sort of a list of dictionary objects. So if I run the blockchain file here, and we'll let it mine the blocks. So we had been creating each block here. As you can see, it's a dictionary. And I guess that's kind of useful to access things, but it's not really that useful, and it's not the best coding practice. So I'm going to change it from a dictionary, a list of dictionaries, to a list of the block object, which we defined earlier here. So in order to do that, I'm just going to simply change this self.chain.append all of this stuff about the block to just self.chain.append block. And then I'm going to add a remove option 2. We don't really need that yet, but I'm going to code it just for the future in case we want to remove a block from our blockchain. And my Siri has just activated for some reason. So I'm gonna have to change the mine function here. So let's change that because we are referencing the dictionary here before. So instead of saying self.chain, the last block in the chain .get the hash, we're actually just gonna hash that because self.chain and -1 is just the last block in the chain and it's a block object. So we can simply call block.hash. Then this code here should work the same. The only other thing we need to change here is this still the same self.add block. So everything should be working now. I'm going to run it again just to make sure. Okay, and now it's actually used our string function that we defined earlier to print the blocks, which is really nice. So everything looks like it's working fine. So the next step that we're going to do is we're going to make sure that our blockchain is valid. So we're going to code a method that can verify that this blockchain is indeed a real blockchain that hasn't been corrupted. And just a reminder of what that means is that each block should start with the number of zeros as defined by the difficulty. Normally that's 4, so each block here should have 4 zeros in its hash. And then the other thing is that our blocks are connected. So this previous hash here is truly the hash of this block here, which we have here. So we're going to check both of those things in this isValid function. So we're going to loop through each block in the blockchain. We're going to loop through starting at the second block because we're going to check the block before each one. So we're going to loop through 1 to the length of the blockchain. And then we're going to check the previous hash of the current block that we're on. So say we start here, we're going to start on the second block. We're going to check this previous hash here. So we're going to access that. I'm going to call that underscore previous. Should be equal to the chain at I dot previous hash. Okay, then we're going to compare that to the hash of the block before, which is this one here. And not just the hash that's written there, but we're actually going to recalculate the hash, if that makes sense. So I'm going to call that underscore current equals self.chain of I -1, so the block before, which explains why we're starting on the second block. And we're going to say dot hash, and we're actually going to call the method hash, so we're rehashing that block. And then we're going to check that those two values are equal. So if previous is not equal to underscore current, then something is wrong. So we're going to return false. But then the other stipulation was that each block starts with 4 zeros, or the number of difficulty zeros. So the way we're going to check that is we're going to say or underscore current, and we want to check that the first 4 characters or difficulty characters, so like we're going to do that like that, so those are the first 4 characters of current, and then we want to see that those are equal to 4 zeros, or 0 times self.difficulty. And if either of these things are true, so these don't match or there's not 4 zeros, then we're going to return false. So if I run the method is valid on blockchain right now, it should tell me that it's true, because if we look at this blockchain, all of our hashes have 4 zeros, and that's one of the conditions. And then also our previous hash here matches the hash of the block here, just like that. So it should tell me that it's true. We're going to run it right now. It's going to remine all of the blocks. And did it say true? Oh, I forgot to write print blockchain.isValid. We'll try that now. Oh, and it says none because I forgot to return true if none of this, if false isn't returned, basically. Okay, so it should say true now. Okay, so that is working, and just to make sure that it is working for a corrupted blockchain, I'm going to manually corrupt our blockchain such that it should say false. So over here, I'm going to say blockchain dot chain, and I'm going to change the third block in the chain, and I'm gonna put some different data there. And what that's gonna do is it's going to make the nuance value. So here, if I change this data from test to new data, it's going to make this nuance no longer give us a hash with 4 zeros at the beginning, and that is going to create a problem. And also, this previous hash will no longer be the hash of this block here. So we're going to do that. Blockchain.chain.2.data equals new data. And then now I'm going to print if our blockchain is valid. So this should say false. And it does. Okay. And the other thing we could check too is that if we were to somehow remine the block, so after changing the data, say our hacker remines the block, as in finds a new nuance that will satisfy this new data, that it will still be corrupted as the chain is off, which was the checking the previous hash, matching the hash of the current block. And it is indeed still false. So our isValid method is valid. It's still working. So that's pretty much it for our blockchain class for now. What we'll move on to now is kind of, I guess, starting our application using Flask, just getting some of the imports set up, and I'll see you in the next video to do that.